Determine the current in all resistors in the circuit shown in the figure. So if you see here, there is a current source and 3 resistors connected in parallel. So current in resistor R1 is I1, resistance of R1 is R2, current in resistor R2 is I2, current in resistor R2 is 1 ohm. The current in resistor R3 is I3 and resistance is 5 ohms. So now this is our source current whose value is 50 amperes. This current will enter into the circuit and it will divide in 3 parts. But if you observe, there is a node here, there is a node here, there is a node here, and there is a node here. Total 4 nodes are there, but since there is no element between these 2 nodes, the potential difference between this node and this node will be same. Potential at these 2 nodes will be same. Hence, the potential difference between these 2 nodes will be 0. Similarly, in this, since there is no element between this node and this node, therefore, the potential difference between these 2 nodes will be 0. So, instead of using 2 nodes, we can use only one node. So, I have redrawn this figure. So, you can see there is only one node here in this branch and there is only one node in this branch. So, now I have only 2 nodes. One node is A, other node is B. So, the current from this source, current source, will travel like this. It will flow like this and it will divide at A. Okay, and all the divided currents will travel through, I1 will travel through R1 and I2 will flow through R2 and I3 will flow through R3, and at last they will meet at node B, and this node where they are going to meet, this other node, will consider it as the reference node and whose value will be always equal to 0. So, at reference node all the currents are meeting. So, according to Kirchhoff's current law, the entering current, algebraic sum of entering currents at a node, algebraic sum of entering currents at a node, that is 50, must be equal to the algebraic sum of leaving currents at particular node. So, I am assuming the node voltage as V volts at node A. Node voltage is V. Therefore, the current I1 is given by V minus 0 by 2 plus current I2 is given by, I2 current is given by V minus 0 by 1 plus current I3 is given by V minus 0 by 5. Okay. So, these are the currents leaving the node A or node V. Okay, node A whose node voltage is V and the 50 ohms is entering current. So, I is equal to V by 2 plus V by 1 plus V by 5. So, 50 equal to V into 1 by 2 plus 1 by 1 plus 1 by 5. Just simplify it, you will get V equal to 50 by 1.7. Now, if we further simplify, V equal to 500 by 17, V equal to 29.41 volts. So, current in 2 ohms resistor is V by R1, V is 29.41 by 2, that is 14.7 amperes I1 current. I2 current is the current flowing through 1 ohm resistor, that is R2. So, I2 equal to V by R2. So, V is 29.41 by 1. So, you will get I2 current as 29.41 amperes. Similarly, current in 5 ohms resistor, that is I3 equal to V by R3, that is 29.41 by 5, that is 5.882 amperes. So, next problem, find the voltage across 30 ohms resistor using Kirchhoff's voltage law. So if you observe here, this circuit has two meshes. This is mesh 1, this is mesh 2, and they have asked us to determine the voltage across 30 ohms. So in this mesh 1, there is a voltage source, there is one resistor and another resistor, two resistors and one voltage source. In mesh 2, one voltage source and two resistors. So if you observe carefully, 10 ohms resistor is common to this 10 ohms resistor is common to mesh 1 and mesh 2. So let us write down, this is mesh 1, this is mesh 2. Let us assume loop current I1 in mesh 1, loop current I2 in mesh 2, and assume some current directions. I have assumed loop current in mesh 1 in clockwise direction, loop current in mesh 2 is also in clockwise direction. So now let us apply KVL in mesh 1. So if we apply KVL in mesh 1, 20 if you apply KVL in mesh 1, this algebraic sum of source voltages in mesh 1 is only one source is there in mesh 1. So 20 volts. So 20 is equal to 5 into I1 plus 10, this 10 ohms into the differential currents of the differential current, that is difference of these two currents. Why we are assuming these two currents as difference? The reason behind that is, if you observe on this side, current is going downward, loop current is going downward, this loop current on this side of 10 ohms is going upward. Both are in opposite direction, therefore differential of these two currents, difference of these two currents will flow through 10 ohms. So since we are considering mesh 1, okay, therefore the voltage drop across 10 ohms is 10 into I1 minus I2. Now simplify it, 20 minus 5 I1 equal to 10 into I1 minus I2 equal to 0, 20 minus 15 I1 plus 10 I2 equal to 0, 10 I2 equal to 1. Now further simplify it. I have divided the above equation. I have divided this above equation by 5. I have got 2I2 equal to 3I1 minus 4. I have multiplied the above equation with 2. No need to do all these things. Simply this equation, whatever you have got, you can consider it as equation 1. I have further simplified it. No need to do this. So multiply the above equation with 2 and you will get 4I2 equal to 6I1 minus 8. Now apply KVL in mesh 2. Okay, this is our mesh 2. Apply KVL. So source voltage, if you see source voltage positive terminal from where current comes out of the source, that direction and I2 direction are same. So plus 80 equal to 30 resistor, 30 ohms resistor into I2 plus 10 into I2 minus I1. Why? Because we are in mesh 2. So we must consider I2 minus I1. Now simplify it. You will get minus 10 of I2 minus I1 minus 30 I2 plus 80 equal to 0. Divide the above equation with 10. You will get minus of I2 minus I1 plus minus 3I2 plus 8 equal to 0. Next minus 4I2 plus I1 plus 8 equal to 0. And further simplify, you will get 4I2 equal to I1 plus 8. Consider it as equation 2. Now solve equation 1 and 2. You will get I1. So I1 you have got as 16 by 5. Now substitute I1 in equation 1 or 2. You will get I2. So this is my I2, that is 14 by 5 amperes. Since they have asked us to determine the voltage across 30 ohms, what is the formula that is I2 into R. So I2 is 14 by 5. What is R value? 30. So 14 by 5 into 30, you will get V30 ohms is equal to 84 volts. So in this numerical problem, we have to find the current flowing through 20 ohms. Where is 20 ohms? This is 20 ohms. We have to find the current flowing through 20 ohms. We have to find current flowing through 20 ohms. And we have to apply Kirchhoff's current law to determine the current through 20 ohms. So if you observe here, there is a voltage source of 20 volts, current source of 4 amperes. We have to apply KCL. So just let us search for the nodes here. So if you observe, this is a node, this is a node, this is a node, and this is a node. But in between these two nodes there is a resistor. In between these two nodes there is no resistor. So therefore the potential difference between these two nodes will be equal to 0. So instead of drawing two nodes, you can consider a single node here. Okay, you can join these two nodes together to form a single node, and you can consider it as a reference node. So I have redrawn the figure. So here node 1, node 1, node 2, node 1, node 2, and node 3. So I have assumed some node voltages V1 at node 1, V2 at node 2, and 3 is the reference node, that is whose value will be always equal to reference node voltage is equal to 0. Now let us assume at node 1, where the node voltage is V1, all the currents are leaving the node. You can assume any current direction, either all currents are entering, some of the currents entering, some of the current leaving. You can assume your wish. So here I have assumed at node 1 and node 2 currents are leaving the node. All these three currents, if you see, they are leaving the node. And at node 3, the node voltage is 0. Now let us apply Kirchhoff's current law at node 1. At node 1. So here current is leaving node 1 and entering is flowing towards source voltage of 20 volts. So current always flows from higher potential to lower potential. Therefore, since current is starting from V1 according to our assumption, so V1 minus 20 divided by 5 will give us the current in 5 ohms. Now current in 10 ohms is V1 minus 0 by 10. Current in this 10 ohms is V1 minus V2 by 10. V1 minus V2 by 10, that is equal to 0. So algebraic sum of all the currents leaving at node V1 is equal to 0. Now simplify it. 2V1 minus 40 plus V1 minus V2 by 10 equal to 0. 4V1 minus 40 minus V2 equal to 0. V2 equal to 4V1 minus 40. Now let us apply, consider it as equation 1. Now let us apply KCL at node 2. So if you apply KCL at node 2, all the currents are leaving. But if you observe this branch, in this branch there is a current source from which current will enter the node. But we have assumed current is leaving the node. So this current is opposite to the assumed current direction. Therefore, minus 4. Okay, this is 4 amperes. So minus 4 plus current in this 20 ohms is V2 minus 0 by 20 plus current in this resistor is V2 minus V1 by 10 is equal to 0. So what is the, according to Kirchhoff's current law, algebraic sum of all the currents equal to 0. So simplify it. So minus 80 plus V2 plus 2V2 minus 2V2 by 20 equal to 0. 3V2 minus 2V1 equal to 80. Consider it as equation 2. Now substitute equation 1 in equation 2 and simplify it. 3 into 4V1 minus 40 minus 2V1 equal to 80. 12v1 minus 120 minus 2v1 equal to 80, 10v1 equal to 200, v1 equal to 20v, substitute v1 in equation 1, you will get v2. We have got v1 20 volts, v2 is 40 volts. Now they have asked us to determine the current flow in 20 ohms. 20 ohms, current flowing in 20 ohms is what? V2 by R. So V2 by R, V2 is 40, R is 20, so 40 by 20 is 2 amperes.